My question was that with other wearable electronics like body suits and things along those lines, how do they envision thermal management for those types of electronics, not just the ones that are the watches or the VR goggles or things like that?
Yeah, for instance, I'm working on a project right now. It's a medical device that's to be worn against the skin. And the first thing we did was we took and did a study of the thermal conductivity of the skin. The body has a core temperature of around 37 degrees Celsius, plus or minus a couple tenths for a healthy person. When we did this thermal study, we were actually able to build a model of the flesh over the core temperature. And then after that, we take and we do a CFD analysis of the unit that's being worn against the skin. And as was mentioned, while the touch temperatures for the hands and everything are somewhat higher, if you have something in permanent contact with the skin for several hours, you can actually cause damage at around 43 degrees Celsius. So we tend to design the unit so that it doesn't get much above 40 to 41 Celsius. And the only way to do that is to keep hot components away from the skin side and make sure that most of that heat leaves through the part that is away from the skin and radiated and convected out into the air.
How well does that work then if they're wearing like clothing or a jacket?
Well, that can be a real problem. When I model it, I do model it with, say, a shirt on, but if they actually have a coat on, that can be a real problem because there's no good way to get rid of that heat except make sure that the device isn't dissipating so much power that it is raising the skin temperature above the actual limit that's allowed for continuous contact. And at that point, about the only thing you can do is start throttling the device with temperature sensors in it to keep things cool enough.
And I'd like to reinforce Guy's position on that. If you look at the IEC international standards for temperatures that are allowed to come into contact with skin, once it's allowed to be in steady state contact, it's basically skin temperature that they're allowing, almost no temperature rise at all. So if you're relying on this device for a health monitor or a sports monitor, well, I'm not sure we have any other ideas yet. Anyone else? How do we deal with these passive devices specifically, or ones that are passive now, as we want more computing, want them touching the skin under our clothing? Anyone? Andy?
Maybe just to comment on the challenge there. The most sophisticated device I know of is myself, my body. And as an engineer, I think for a long time I didn't want to admit that. And even topics like biomechanics, the body is so amazing that and you're threatened by it as an engineer. It's the level of complexity and all the things it does. And so when you start putting things on it, it's just not a trivial problem at all. And the amount of work to go figure out when skin is damaged and all the different people and age groups and you end up not being able to hardly tolerate anything when you're doing a product that spans every person. Yeah. The point is that it's really challenging. It takes it up quite a bit.
Okay. Emil, Jay, any other comments to add?
Just one quick comment, and again, it's to reemphasize how big this challenge is. We need maybe to develop something to decouple the heat source from the body as much as possible. And we never thought, in thermal management much about insulation. We're always trying to spread the heat and trying to, isothermalize something. But when it comes to permanent or constant contact with the skin, this is something worth looking at, how we can actually insulate and protect the skin and direct the heat away in a different direction.
Oh, there we go. If I'm not mistaken, the translating Google earbuds actually rely on computational power on the user's belt. Okay.
Absolutely.
I think as long as you don't put that on your head, then it's challenging, but we will find a way to manage the heat. But if it is on head, then it's very challenging.
Gabriel, are people going to go for consumer devices where you have to have two different parts? One's the convenient one, and one is kind of the computer that's got to be on your belt or, you know, in your purse or something?
The example was given about the cloud, right? This is, Emil, I guess, talked about that. I believe that us in this room, we're here to stretch the envelope. You can stretch it so far. And after that, you have to go back to the fundamentals. That means you have to look at a semiconductor that can do more with less power. Have to bring the power back.